Okay, hopefully we're recording this time. I think I did the best explanation I've ever done for piecewise functions and it wasn't recording, so let's try again. So for 7 and 8, we're going to look at these together. They're going to ask us for 7 to graph this function. Piecewise functions means there's multiple pieces. This little inequality section, or quality, if something's happened, this is what we call our domain. So the domain of the piece. Maybe I'll get a little bit better here. This part of the function is called the output, or how you calculate it. And we want to think of these as, especially these, since they're really all constants, we want to think of these as y equals -1, y equals 2, and y equals 3. Now y will be equal to -1 whenever x is less than 0. So usually what we do is we look at this piece first, but again, as we read left to right, so sometimes we forget to do that. So this is the piece of the function whenever x is less than 0, not equal to 0, but less than 0. This is the part of the function when x is equal to 0. Okay, and this piece will be x being greater than 0. Okay, and so to graph this, here's our x, here's our y. So we start with when x is negative, when x is less than 0, this whole back part, y is going to be -1. And there's no x to plug in here, so it's a constant function. Again, at 0, no, not -1, but anything less than 0 is going to be at -1. So it's a horizontal line going backwards. When x equals 0, we're told that the function value is 2. So we put that in there. And that's all, just one single point. When x is greater than 0, we're told that y is going to be equal to 3. So again, at 0, we have an open circle for here, and then we get this horizontal line at 3. No place to plug in the x or do a calculation. It just is going to always be, y is always going to be 3 whenever x is greater than 0. There's our graph. Okay, so that's how we do piecewise functions when we have constants as our output. These are constants, right? No variable. Let's take a look at 8 and see how we do this. And we're not going to actually graph it, but we're going to look at plugging in some x values to find the y values. And in this case, part of the function is variable. It's got a variable x right here, and part is constant. It doesn't have the variable. Okay, so again, this first part is our domain. So it tells us whenever x is not equal to -2, then we're going to use this part here, y equals this -3/4 x minus 1. Whenever x is equal to -2, in this special case, y is going to be assigned the value of 2. It'll be equal to 2. Why? Just because it is. So first thing we do, -4 is an x value. We check which domain it's in. Well, x is not equal to -2, so it goes with the top one. So we're going to plug in -4 for x. Okay, so this one we get by going -3/4. Plug in the -4 for x, and then do the calculation. So we do 4 divided by 4 is 1. A negative times a negative is a positive, and so we've got a +3 minus 1. Our final answer is 2. I notice we would have got the same answer here if we would have went to the wrong place, but we would have got it in the wrong way, so we want to do it in the right way. Now, when x is -2, we don't come back up here. We don't plug in 2 for x because it's not in this domain. It's in the second domain, and we're just told that y equals 2. There's no x to plug in. It just is our +2. Y is equal to +2. That's our answer there. When f of x of 1, or f of 1, when x is 1, let's put it that way, we check the domain. Nope, it's not, x is not -2, so we're back up here again, so we plug in 1 for x. -3/4 times 1 minus 1, that's going to be 1 times 3/4. -3/4 is -3/4, and then we need a common denominator. Just remember, 1 is always same thing in top and bottom. So with the common denominator 4, we can rewrite 1 as 4/4. Right? That's another way to write 1. And then now that we have a common denominator, we combine the tops. -3 minus 4. It gives us -7/4. So there's our 3 answers with a piecewise function. One part variable, the other part constant. Thanks.